Welcome back everybody to C# Tutorials for Beginners. This is number 5 and today we will talk about operators. Okay, so first take a minute to get your code looking like the template with our readline call so it's nice and clean. Okay, for the purposes of this tutorial we aren't going to cover every operator in C#. We are going to hit a lot of them, and the categories are math operators, assignment operators, relational operators, which are also called comparison operators, and logical operators. So first we'll talk about the most basic of operators, and I'm sure you have heard of them. Those are addition, subtraction, multiplication, and division. So if you have a variable, let's use our int variable and say we have a number 1, and that number 1 is equal to 3. Then say we have a number 2, and that is equal to 4. Now let's say we want to get the result of number 1 plus number 2. Look, it fills this in for us, and we can hit tab to populate it. So we are using the mathematical addition operator here to add number 1 to number 2. And now let's take our right line call here. Let's copy it. Let's comment out hello world. Let's put it here. And now let's take result, copy it into here. So you notice it's not a string because we're printing an int. So it will automatically turn it into a string when it writes it for us. And when we run this, we will see 7. So we get 3, 4, and then we get 3 plus 4 into the result, and then we are writing the result to the console. The other operators work the same way. So if you want to subtract them, multiply them, or divide them, you do it the same way. You just switch the operator. One thing worth noting though, and this is important, you need to make sure that your variables that you're adding together or multiplying together are the same type as the variable that you're reading them into. So we have int plus int equals int. We have all the same types. Now, it is definitely possible to change types and mix and match types in various ways. But that's called typecasting, and it's a little more advanced than where we are, but we'll definitely get there. So for now, just keep your types the same. Now, before we move on to the next operator, I do also want to remind you that an integer type is a whole number. So say we did int result equals number 1 divided by number 2, and say we did 8 divided by 3. So if we divided 8 by 3, we would get some number point some other number. But if we do 8 divided by 3 as an integer, what we're going to get is 2, because 3 goes into 8 2 times evenly. So if we wanted to do this division, what we would need to do is change our types to doubles. So if we changed all of these types to doubles and ran it again, you're going to get your remainder here. The next operators I want to talk about are increment, which is a plus operator, and it adds 1 to a number, and decrement, which is a minus, and that subtracts 1 from a number. Now these work a little strangely because pre or post matters. For example, plus number is different than number plus. So let's go over that. So let's make a new number. Let's make int number 3 equals 5. Now, let's take number 3 and put it straight into our right line. So if we write number 3, we know we're going to get 5. So then, we know that plus adds 1 to a number, and we know it acts differently if you put it on the front or on the end, but what exactly does it do? So when you add a plus, it splits it into a different execution. If it's on the front, it executes that first, and if it's on the end, it executes that last. So if we said write line plus plus number 3, it's going to say, okay, number 3 equals 5. Then it's going to say add 1 to number 3, and then it's going to say write number 3. So this would actually end up writing 6. We can show that here. So that increment happens first before our print. So say, comment that out. Say we did, oops, shouldn't have commented that. Say we did write line number 3 plus plus. So what's going to happen there is it's going to say, okay, we want to write the number 3, and then we want to increment it. So what's going to happen here is we are going to print 5 because it prints before it increments. So we can run that and we get 5. But in our code, after the print statement, number 3 is actually going to be equal to 6. It just didn't increment it until after the write. So if we came over here and wrote number 3 again, so what would happen is number 3 would be equal to 5. Then we would print number 3. We would increment number 3, which would be 6. Then we would print number 3, which would give us 6. So we would expect to get 5 and then 6. And that's what happens. Many times that you use these increment and decrement operators, you're going to be using them as a standalone way. So if you said number 3 plus plus, and then you said plus plus number 3, and then you went on about your business, they would act the same way. This would increment, and then it would go down to this line of code, and then this would increment, and it would be basically the same thing. So that's why I wanted to give the example inside of another call so you can see the order that it occurs depending on where you put the plus plus or the minus minus. The minus minus operator, the decrement, subtracts 1 instead of adds 1, but in every other way it acts the same. So let's move on to another operator, and now we're in a different category, the assignment operators, which the first assignment operator is equals. So if we have number 4 equals 6, this is our equals assignment operator. So we already know that one. But the ones that we haven't gone over are plus equals and minus equals. Before we move on, let's clean up a little bit. Feel free to save any of this off as notes. And then let's take the assignment and pull it all the way up to the curly brace. Let's take a console write line so we can print. And now it is a little bit cleaner. Okay, so we talked about plus plus and minus minus, which add and subtract 1 from a number. Now let's talk plus equals and minus equals, which you can use in very much the same way, except you give something on the right to see how much you're adding or subtracting. So if we add another variable, we can call it number 5. Let's make it equal to 5. Now if we said number 4 plus equals number 5, what we are doing is we are saying number 4 is equal to number 4 plus number 5. So what you're going to get is 6 plus 5 equals 11. We can print that. And you get 11. Similarly to that, you don't have to have a variable. So say instead of using the increment operator to add 1, maybe each time you wanted to add 2 or you wanted to add 3. So instead of doing plus equal another variable, you could say number 5 plus equals 2. And that would do the same thing, except instead of adding it to a variable, it would just be adding a static 2. And minus equals works the same way, except it subtracts. And there are also other operators that work the same way. You can do multiply equals, divide equals, and others too, but just wanted to give you the basic concepts of what these operators do and how they work. Okay, now we are done with assignment operators. Let's blow this away, get a little cleaner, and take our right line down to our relational operators and start there. So relational operators are also known as comparison operators, and they have two main categories. The first one is equality, and the next one is math comparison. So in the equality, you have, are two things equal to one another, or are two things not equal to each other? So the exclamation in this language is very often used to mean not. Then the math comparison operators, those include the common ones such as greater than, less than, greater than, or equal to, and less than or equal to. Okay, let's start off by making a couple of variables. Let's do int minutes equals 60 and int dollars equals 5. So when making a comparison about equality, we know we're going to get a yes or a no, or in our case, a true or a false. So what we want is a Boolean, and maybe we want to say is exactly 1 hour. Well, how do we know if it's exactly 1 hour? We could say, is our minutes variable equals 60, because there's 60 minutes in an hour, and depending on what's in this minutes variable, if it is equals to 60, then our Boolean is exactly 1 hour is going to be true. So we can test that by writing this out. So that is true. But say we only had 58 minutes in our variable. Now all of a sudden we run it again, and it's false because our minutes does not equal 60. Okay, now say you're writing a stopwatch program and you want to know, has your stopwatch started? So we have a minutes here, and we know in a stopwatch that are going to go from 0 up. So we could say, has stopwatch started? And that could be equal to if our minutes are not equal to 0. So our minutes are 58, and it's not equal to 0, so we could assume our stopwatch has started. So that would be true. But if we checked when our minutes were 0, then we would know that our stopwatch has not started. So has stopwatch started would be false. So I know that the format of this, you've got a variable, and then you've got an equals, and then you've got a variable, and then you've got an equals equals. It could be a little daunting. So if you want to make it a little bit easier to read at first to understand, you can surround this equality in parentheses. So you know that this whole unit is your calculation, and you're setting your variable equal to this calculation. That might make it a little bit easier to read if you want to do that. Generally, you won't see this kind of calculation being assigned to a Boolean because most times this kind of calculation is in an if-else or other sort of conditional statement. We just haven't gotten there yet, but we will very soon. Let's talk about math comparisons. Sometimes you don't need an exact equal match. You need to know if something is just less than or greater than something else. So let's say we want to see if our bank account has met my goal. Okay, so let's make a goal. Let's say our goal is 100. We'll call this goal dollars. So $100 is our goal. So if the account has met the goal, if our dollars is greater than or equal to our goal dollars. So that's saying if our dollars is exactly, that's the equals, 100, or is higher than 100, we know that we have at least met our goal. We can check that here. We have $0. Our goal is 100. We have not met our goal. If we change our dollars to 100, then we have met our goal. If we have $105, we have still met our goal. Sometimes you don't want to check or equals to because you only want to know if it's greater than or less than something. So say you want to know if your account has money. You would check to see if your dollars are greater than 0. If they were equal to 0, you still wouldn't have money. So if we put our account has money here, give ourselves $0, false. Our account does not have money. We have $1, account has money is true. Next up, let's talk about logical comparisons. So we have and, or, and not. Logical comparisons get one step deeper. So our equality checked values, our math comparisons checked values, but our logical comparisons will check Booleans. For example, you might say, account has met my goal and account has money, and then that would return its own Boolean. So let's add another variable, and let's make this variable a Boolean. Let's just say, is account active? And my account is active, so I will say that that is true. And for our logical comparison, let's see if account earns interest. Now for our account to earn interest, it needs to be active. So we'll say, is account active? But to earn interest, we also need to have money. So we could also say account has money. So again, we can put these in parentheses to make them a little bit easier to read. So now what this is going to do is it's going to declare this variable, account earns interest. And now it's going to say, okay, is account active? So it's going to go check this. This is true. So then it's going to come to this and. Now, if this had been false and it got to this and, we would stop immediately and go to the next line of code, and this would be set to false because it doesn't need to know anything else about what's happening because this is false. So the and has to have all trues to be true. So then it's going to say, okay, this is true, and now it's going to check account has money. If the account has money, which dollar is greater than 0? We have $1, so that would be true. So account earns interest would be true. So we can move this down, put this in here. And we can see that our account earns interest. So what if we wanted to see if our account charges a fee? I would think that if our account is active, they're going to charge us a fee. Or even if it's inactive, if our account has money, they're also going to charge us a fee. It's important to note that with a logical or, that if any one of the items is true, this is going to be true. So it's not saying this can be true, but this can't because it's one or the other. If any of these items are true, this is true. So our account is active and our account has money. So both conditions are met, so it is going to charge us a fee. If our account becomes inactive, but we still have money, it's still going to charge us a fee. So only if we have $0 and our account is not active is it not going to charge us a fee. We finally made it to our last operator, and that's logical not. Logical not is a lot easier if we explain it with its own Boolean, and let's just call it running. So we have something that's running. Well, we have another Boolean called stopped. So if it's not running, it's stopped. So all we have to do is say not, which is the exclamation point, running. So if it's running, then stopped is not running. So same token, if our account has money, we could check to see if our account doesn't have money by putting an exclamation point in front of it. So this would say, is our account active, or does our account have no money? So all it does is flip a bool from true to false or false to true. So if we put stopped in here, we know it's running. So now we're checking if it's stopped, which is false because it is running. Thank you for sticking it out, everybody. I know that was a long one. Next up, we're going to do typecasting, and then we'll get to a little bit more fun with user input and things like that. So thank you for watching. I do appreciate you. Until next time, as always, take care.